Alright guys, today we're going to learn about adding and subtracting polynomials, but real quickly I wanted to review with you guys about combining like terms. So if I zoom in on number 1 right here, we're looking for like terms that we can put together, and I see negative 3x and negative 9x are like terms because they both have the variable x to the first power. So I can combine those and put negative 12x. Then I also see the like terms positive 4y and negative 5y because they both have y to the first power, so that means they're like terms. I can combine them and I can say negative 1y. Now I really don't need to put the negative 1 there. I could have just wrote negative y, but this is perfectly fine. This is me combining like terms. Number 2, again, I'm looking for like terms with 2xy squared. It has to be x to the first power and y to the second power. And the only other one I see that has x to the first power and y to the second power is this term over here. So I can combine the 2 and the invisible 1, and 2 plus 1 gives me 3. And then I bring down my x, y to the second power. Then I go up here to the next term, x squared y. And when I look, there are no other x squared y's. So I can't combine him with anything, so I just bring him straight down. Finally, I look at the other term that's left, negative 7xy. There are no other terms to combine with negative 7xy, so I'm just going to bring him down, negative 7xy. And this is my answer when I simplify by combining like terms. Number 3, again, we're trying to combine like terms, and the 6 is all by himself, so there is no variable, so I'm looking for anything else that doesn't have variables, and he's the only one, so I'm going to bring him straight down. The negative 1m squared, or negative m squared, combines to this m squared over here, and negative 1m squared and positive 5 combines to give me a positive 4m squared. And this is my answer when I combine my like terms. All right, number 4, I'm hoping that right off the bat that this right here looks goofy to you. Negative 4k. Whenever we have double symbols like that, that should always be a red flashing light that something's wrong. So in negative situation, we always change it to plus positive. So what I'm going to do is I'm going to rewrite this, but instead of minus negative, I'm going to put plus 4k. And I'm just going to bring everything else down. Alright, now that I've fixed that, now let's look at like terms. I have a number that's all by himself, so negative 8, positive 7, and positive 1. Those three are like terms, so I can combine all three of them together. And negative 8 plus 7 plus 1 is actually 0. But I don't need to have the 0 down there, so I'm going to go back and I'm going to erase him. So even though I combined those three, there was nothing there. Then 4k and negative 4k. Well, positive 4k and negative 4k are like terms, and they cancel each other out. So my answer is nothing down here, but I just can't turn in an answer that says nothing. I have to put something there to represent that nothing is my answer, so I would put a 0. All right, now we're into the actual notes of this section, and if you would look, what we're learning today is we have a binomial plus another binomial. That's what we're going to learn first off, is how to take a binomial plus another binomial. Now the trick to doing this is whenever it's adding, it's a binomial adding another binomial, you can bring this straight down without the parentheses. And plus 6m squared minus 7m to the fourth. Now once I bring it down without the parentheses, it's just like the first 4 problems I reviewed with you. 8m to the fourth can combine with negative 7m to the fourth, and that gives me 1m to the fourth. 8m squared would combine with 6m squared, and that would give me a positive 14m squared. There are no more like terms, so this is my answer. All right, now number 2, we have a binomial minus a binomial. Now when it's minus, it's not as easy as when it's addition, so we have to do a little bit of work here. The work we're going to do is called the distributive property. So I'm going to bring this first binomial down without the parentheses, and then negative times 5n to the fourth is negative 5n to the fourth, Negative times 7 is negative 7. Now, once I've distributed my negative symbol, now it's just like the first 4 review problems we did earlier. 8n to the 4th would combine with negative 5n to the 4th and give me 3n to the 4th. Positive 8 and negative 7 would combine to give me a positive 1. And this is my answer simplified. All right, number 3, we have a binomial minus, that means we're going to have to do the distributive property here in a second, a trinomial. So again, a binomial minus a trinomial over here. Now again, whenever we see the minus symbol between the two polynomials, that means we're going to do the distributive property. So I'm going to bring down the first binomial without changing anything. Negative times 2p to the 4th is negative 2p to the 4th. Negative times negative 7p squared, and negative times negative is positive 7p squared. And negative times positive 6p to the 3rd is negative 6p to the 3rd. And again, we're just going to look and try to combine like terms. I have an invisible 1p to the 4th and a negative 2p to the 4th. And those are the only ones that have p to the 4th power. So I'm going to combine those, and I get negative 1p to the 4th. And I'm going to go to the invisible 1p squared, and I can combine him to the 7p squared, and that would give me 8p squared. And finally, I have a negative 6p to the 3rd. Doesn't combine with anything, so I just bring him straight down. Now, if you remember from the last section, we always write these in what's called standard form, which means they go in order of the degrees. So I would rewrite this, and I would write negative 1p to the 4th, negative 6p to the 3rd, and positive 8p squared. But honestly, either the answer in green or red is going to be fine with me because I am not there to help you with this, and we're all doing this online. All right, number 4, I'm going to work this one a little bit quicker because I went slower on the first ones to explain it, but we have a binomial plus a trinomial. Now again, whenever it's adding, we can pretend the parentheses aren't even there. We can just combine like terms. So I have 4p to the 4th, 8p to the 4th gives me 12p to the 4th. 5p to the 3rd and negative 3p to the 3rd gives me 2p to the 3rd. And then finally, negative 3p squared, there's nothing to combine with it, so I'll bring him straight down. And here's my answer. Number 5, we have a trinomial minus, that means we have to do the distributive property, another trinomial. So again, we need to distribute this minus symbol first. So I'm going to bring everything down on this trinomial because there's nothing to do yet over here. Negative times 4 into the second is negative 4 into the second. Negative times 2 into the 3rd is negative 2 into the 3rd, and negative times negative 8n, and negative times negative is positive 8n. From here, I'm going to look and combine my like terms, and I'm going to put it in standard form as I go. So that's why I'm going to say negative 2 into the 3rd, and negative 2 into the 3rd gives me a negative 4 into the 3rd. And then next up on my standard form would be squared, so 5n squared, and minus 4n squared would give me a positive 1n squared. And again, you don't have to write that invisible 1 there. I did to help you out. Finally, we have negative 8n to the 1st and positive 8n to the 1st, and they cancel and give us 0. But again, I don't need to put the plus 0 out there, so I'm going to go back and erase him. And this is my answer. All right, number 6, again, we have a trinomial minus a trinomial. The minus in between the two polynomials means we're going to do the distributive property. I'm going to bring the first side down because, again, there's nothing to do to it yet. Negative times 6a is negative 6a. Negative times 2a squared is negative 12a squared. And negative times negative is going to be positive 8a to the 4th. And again, I'm going to put these in standard form as I go. So I'm going to start with the a to the 4th. So negative 8a to the 4th and positive 8a to the 4th cancels out and gives me nothing. So I'm not going to bring anything down for them. Next up would be the a to the 3rds. There are no a to the 3rds, so then I go to the a to the 2nds. So I have negative 12a to the 2nd, negative 1a to the 2nd, which would give me negative 13a to the 2nd. And finally, I'm going to go to the a. So positive 4a, negative 6a combines to give me negative 2a. And this is my answer.